Good afternoon. This is Alex Maverick here presenting for the month of March the Bentley Special Interest Group. For today, we are going to be presenting you the enhancements in 3D model that we have included in OpenBridge Designer. And also, we're going to get a sneak preview of what is coming on our next release that is going to be in actually April. So, next month, we're having a new release of OpenBridge Designer. So just as a summary of what we have today, the software is available today and what you can do with it, right? We call it primary enhancements, in which we have included earthwork excavation volumes, beam hunches, there's new options there, beam rotation when you do U-beams, the addition of transition piers when you have different piers types, like for example, going from a concrete to a steel bridge, right? Orientation of cross frames for steel bridges, the option to place custom piers, and now on the next release, you're going to see the great new enhancement that we have on placing custom substructure elements, not only piers but abutments as well. How we placing auxiliary elements, light poles, barriers, and the tools that we included as well, as you may already know, clash detection, super elevation, and new terrain tools being added to the release. The current release, it's 10.04, right? When we move to next month, it will be the 10.06. So look for that. I would say at the end of April for sure will be posted. Of course, they also have additional enhancements. The on hunches, the way to go from RM to OpenBridge Modeler and sending information like tendon layouts, better deck elevation reports, adjustments on the path on the Liebridge concrete and Liebridge steel parameters. Well, we're going to go into detail when we go into this, okay, into these slides. So, well, let's go with the list of primary enhancements first, right? So what we have is now the ability to calculate excavation volumes for footings and abutments. The only thing that the user needs to input is the side slope, how you're going to go, how deep you want to go, right? Or maybe you want to do a vertical cut, right? So, and that's the input, the manual input that you need because the software will pick up the terrain, the ground information, and just compute, basically create the hole where your footing will be located, right? And then giving you not only that excavation as a terrain tool, but as well, you can assign cost to the volume that is being removed. Right? So these are the parameters that you can enter. The horizontal offset, so 5 feet away from my footing, right? And since the footing is rectangular, for example, right, have to round the corners. So I want to round it 5 degrees, and I want to go 2 to 1 going down to a certain elevation. So that is the parameters that you enter by hand, and the software will take charge to compute the different excavations that it needs below every footing, or if you have, for example, a 3-column pier with 3 isolated footings, right, it will create one big excavation volume encompassing that 3 footing elements. Right? So how this is done? Well, actually it's very simple. It's an icon in the ribbon that says place excavation. You select the footing, right? Or the pier, actually, the pier element that you want to apply to it. You can apply feature definitions. You can apply specific names. So this could be excavation 1, this could be excavation 2, and so on and so forth. The offset that you want to go, as I said before, the slope, and the sweep angle for rounding the corners along that offset. And pick, of course, the DTM or the ground or the terrain, as we call it now, to compute that excavation. So follow the prompts, locate the terrain model, right? You will locate the Pier 2, and the software will just uh, excavate for you, give you that volume quantity if you need to, right? And as it's being selected, right, you can do multiple ones. You keep snapping to different piers, but if you just select one, that will do it. So now this volume or the excavation becomes an entity, meaning that if you go to the project explorer, you will see that excavation uh, as part of your properties, as part of your bridge. So it becomes a property of the pier, and of course the pier is part of the bridge. So that excavation volume and the actual shape of the excavation that you have done becomes part of the bridge itself. Okay, and it's also a microstation element, so you can go on as you saw. I can delete it as well, right? So as simple as it can be. Obviously, we have received enhancements requests as how we're going to do if we want to deal with different materials, different elevation types. So, well, it's just part of the enhancements request that we have already. One of the other enhancements that we have calculated and implemented is the hunch. This is kind of sometimes tedious, sometimes even difficult geometric calculations, right? And it mostly applies, of course, for concrete beams, right? In which the user can specify now a hunch at the beginning and at the end of the actual beam. Before it was only one, right? Applied to all the beam. But then, if we have elements like the bridges on a vertical curve or stuff like that, so it was a matter of even playing with the numbers to get the numbers what we need or check. Right now, you can specify two different hunches to the beginning of the bridge, and we just can compute it. But the caveat here is that this hunch is always computed. It's always computed for us at the center line of the beam, right? So, uh, so then on that case, if you're doing that, you have to still check, right? Is that th- eh, that some of the dimensions, if the bridge is on a heavy skew or a super elevation, so maybe your minimum hunch will could be violating certain elements that you don't want. So you still have to perform, I would say, a little bit of a manual calculation to get the minimum hunch that you want to apply. But remember, we computed at the center line there, right? Now, as I said before, here, so previous releases require one minimum value. Now we can have hunch at the beginning and at the end, right? Now, if you see, I mean, the beauty of that is that if the concrete beam overlaps the deck at a certain point, depending on the super, the deck itself, so then you have a warning saying, you are violating this, you have to increase that. But that's our manual, that is our manual slash automatic calculation that we offer. But we know that different agencies, organizations, they have their particular way to compute this hunch. So then, therefore, we can provide you I would say, standard values, and then you just have to tweak it according to your agency needs. Another enhancement that we have is the beam rotation option. This was done especially on the yaw girders, in which due to the super elevation, some of the girders need to be rotated to accommodate and be snapping to the bottom of the deck with the hunch tool. So we have this option, and it's just a toggle, very simple to achieve, on the sense that we just say, hey, use the beam rotation, and the beam will just be rotated, right, according to that. So that is, as I said, it's a minor enhancement on the sense that the application is really quick. On the beam ground properties, you just say use the beam rotation. but in terms of geometry, it's big because, basically every beam along your beam layout will be rotated, matching the deck super elevation, for example. Another option that we have here is that, and this is a major enhancement as well, now it was a major request for many, many users, the ability to handle transition piers, right? And that is a perfect example on real life. What a transition pier is when you have a bridge that maybe the longer span is steel, and then the other ones, the shorter ones, typically are concrete. So you have the same bridge, right? But with two different elements, concrete and steel, right? Before we were not able to do that because, again, when you enter in OpenBridge Modeler, you will say, oh, I need to do a concrete bridge or I need to do a steel bridge, not kind of a mixed bridge here. But then that's when the concept of units come into play. We're going to see that, right? And then not only that, but one pier is handling steel and concrete at the same time, and usually with different depths. So the enhancement here, it recognizes that it's a mixed bridge, right? Or two different units, as we call it now. So it applies the proper beam seats uh, on the different heights of the concrete beam or the steel girder, right? So how you do that? The process is it's simple because you create a bridge, right? So let's see, I'm gonna go a shorter bridge, right? And when we do that, we just create a new bridge, right? And it's gonna be a pre-stressed girder, but that's when the concept of unit comes and say, oh, it's gonna be one the first unit of the same bridge. So BR1, unit 1, made of concrete, and later we're going to create bridge BR1, same bridge, but unit 2, right? So let's create first, very quick, the first bridge, the concrete one, and I'm going to do it very quick, a multi-line supports, and place some beams there, right? Just to illustrate the concept on how the process is created. So we know how to manipulate by this time, how to do with OBM. If not, well, I mean, I can refer you to other training guides or SIG meetings in which we have placed these bridges in with a slower pace and greater detail. But here we're just placing a bridge, very quick, right? So, and then I have to complete it. I have to go with the deck, with the beam layout, and placing beams. So we do that, and the beam layout too, right? And a couple of beams here and there, very quick. So I have the beam layout, and now I'm going to place a beam. On that, I'm going to place a big beam, so you will see the difference when I go with the smaller steel eye girder, what it does. So just pick one beam with 63, so and 72 is okay. So 72-inch height, and that I got my beams, right? So now, got it. So now, at this end, I'm going to apply now um, a steel bridge. Okay, but hold it, this is the same bridge. So now we don't create a new bridge, we add a unit, right? So it's the same bridge, BR1, but on that bridge, that if I double check on my Explorer, right, I have BR1 and it's unit 1 made of concrete. So now I will say I need to add a new unit at the end of the bridge. Remember, it knows the end because of the stationing, right? So that's it. It's unit 2 made of steel at the end, right? So accept it on the screen. I don't need to snap to anything, right? And you may see a problem here because it goes on top, right? But don't worry about it because when you start placing the supports, that yellow text that it says, or excuse me, the green text that says Unit 2 will be moving forward to accommodate to where the new location is. So I will make it very simple. So it's going to be two supports because I need only two, right? Because the third one, the first one is the transition one, right? So that's it. So I got a two-span steel. As you saw, the ribbon changes now, so it's placing all steel-related stuff. So I go, well, I forgot my deck, right? I'm going to use the same deck, beginning to end, done, got it. So now I go the beam layout, and I'm just laying out the steel girder, right? I'm going to place a section that is actually small, so you will see what happened there. So that's that. And I will select, as I said, a small girder. You know that we can do a roll shape or a build up. So just for the sake of time, I will just use a small section there and you will see that it will be completely uneven and not much closer as I wanted. But then it will illustrate the concept of doing this as a transition pier. So now it comes that. So you see how the yellow and green text, it knows now that one is unit 1, the other one is unit 2. And on the same bridge, BR1, I have two bridges. Excuse me, two units, right? Two units, one of concrete, one of steel, within the same bridge. So right now, that is the pier command, and then there is nothing special. You just place the pier, and the software will just recognize that it's between two units, two different kinds of bridges, and it will just place it in this case, following the lowest one, right? And then you have to do it applying beam seats, right? So place it, adjust them by deck, and horizontal offset, and you got the pier there, right? So let's place it, and now it will be placed on that one. And did I select it? No, I think I did. That's it, right? So it was placed the cap following the lower beam, right? I didn't need to tell it on what the unit is doing that. It just knows that it's a common support shared by these two. And now when you place bearings, the software will just compute what height of bearings it needs to support fully the concrete one, and then make it bigger to support the steel one. And this process is completely automatic, right? And as you will see, that will do the calculation, and then of course you will get the beam seat reports, the beam elevation report, and so on and so forth. right? So it will be just part of your regular reporting there, right? When you finish these calculations there, right? So when it does that, and it will just do it for you. So that is the option of transition peers. Now, to note here that when we do these transition peers, when you send it to calculations, to analytics, so one section, this section from here to here is concrete, including the pier, will be sent to Libridge Concrete, and this section, including the pier, the transition pier, all the way to the end, it will be sent to Lip Steel. Right? It ups to the user, to the engineer, to transfer the dead loads that are coming when it's analyzing the concrete one. It needs maybe to bring the loads that are coming from the steel part and apply to the proper bearing into the pile cap, okay, and vice versa. So that is left to the engineer's criteria to apply that dead loads, right? So also something very quick here, an enhancement that it seems minor, but it's in geometry calculations is big, is now that we can place the cross frames and the flanges that accompany them to following the cross frames too. See, applicable to cross frame and stiffeners, we can align it normal to the flange or vertical on that. So, and it's just a matter of toggle this when we apply it, when we lay out cross frames. You know as well that you can create the custom piers, completely custom, basically creating a microstation cell and snapping that cell to the bottom of the beams, for example, right? But this is this is for this April release is suffering a major enhancement on that, right? And on that, right? So, but then again, you can just place a custom pier, creating a microstation cell, right? But it's a custom cell. So even if you need to, you created this cell supporting 4 beams with the beam seats to 5 beams, uh, it will just, you can just do it. I mean, you have to redo it every time, right? So if the cap moves or the bridge moves, well, you have to place the beam, the pier again. So it's not functionally working or reacting parametrically. It's just more of like a snapping a cell there. And especially here, oh, this is too wide that I need to adjust the beam. So in this case, as you create the cell, well, you have to recreate a cell just for that bridge, right? So that's a custom pier right now. But in April, well, you will see what is coming, right? So jumping into that, and then this is what we're doing for our April release, right? Is the adoption of functional components, right? And on functional components, what we're trying to achieve is that a functional component is something in MicroStation. I don't want to just read the whole thing, but it's in MicroStation in which you can create your own parametrics, right? Here, for example, in Bridge, in OpenBridge, we just basically say that, we can say internally in the software, and you can just have a toggle to it that says, I want to accommodate the back wall of my abutment all the way up to the top of the deck, right? And then also when you place a pier and then you place bearings, the software automatically lowers the pier to accommodate or make room for the bearing and the beam seats, right? So that functionality is already implemented into the software. But then what about if you want to apply your own functionality? What about if the abutment that we offer is not exactly what your DOT wants? They use something special, or you want to create a really custom architectural pier that you want to accommodate when the super elevation changes, when the beam seat elevation changes, right? So with the Connect Edition, this concept is further enhanced on making use of parametric cells and that functional components that I'm talking about, right? So now what you need to do is first, as it says here, identify. Do you really need a custom cell to replace the structure that the OBM maybe doesn't offer to me? So then you say yes, so then, well, we have to study how to create first a parametric cell, right? So, but this parametric cell means that some of the dimensions could change by hand, right? And so then you can just type the new dimension and the cell, the cap may get longer, wider, deeper, or the column as well. So you will apply certain constraints to the microstation cell that you are creating and just save it in OpenBridge Modeler as a cell library. So you deploy it, and basically what you create is a set of cell libraries with all these parametrics included. The beauty is that when you apply the proper variables to this parametric cell and use it inside OBM, we understand that you are not placing just a cell, you are placing actually a pier, and it goes to go down when you place bearings, for example, right? Or it has to go skew when you skew the angle of the support, right? So you have to think about it, how much constraints you need to apply to your cell, right? So for example, if this dimension from here to here moves, should this want to move as well? Yes, right? So if this goes up, what happened to this element? Oh, all these have to go up because they have to accommodate for the wall. So you have to think about it and make it as parametric as you want it to be, right? So as you do that, all of these could be represented on regular numbers or just variables if you want to, right? But these variables are control dimensions. So you basically, when you dimension, you will just say, oh, these represent the width of the footing, the length of the footing, right? And the variable could be a distance that you can just activate. And you can constrain it and say, when I move the length, so then the dimension on top needs to get longer too. So this is what you will do, right? So let me show you an example, right? So again, in this new release, is coming only for substructure elements. So later we're going to be tackling superstructure. So let's go with it, right? So that's my bridge, right? And then I will just place a pier. So for the regular user, it will just place, as I showed you before, the custom one, but then it's going to be a parametric, intelligent, functional one. And look at the difference now. Before, when we placed the cell, it was just placing this cell, right? But now this functional cell that we have created, like this abutment, as I selected, these are the variables that myself as a user have defined, right? So I can just click it and then place it with the dimensions that I want. So for example, here we're just going to place it, right? And look, this has a cell and it's parametric. The other ones no. This is also a parametric one. You see the variables? This is all as a user I define what I can change when I created this cell, this 3D cell, right? So I just apply it as a standard one. I select the support and it just goes below. And I got it, right? Apply functions, but then now this element is not just a regular bridge element, but look, these are all the variables that I can define, right? Maybe too much, but then look, change the depth of the footing, I don't need to redraw the cell. It just does it because that's my functionality that I added to this dimension, right? And it's just part of it. So now it's, you see, it's below the cap. I mean, it's below the beams. So now when I place beam seats, it knows that it is up here and it will just move down accordingly. So I can make it as parametric as I need with all the dimensions that I apply to it, right? So I said, this is an example, so we just place everything and make it, handling almost any type of hammerhead here, right? So, but then what you have to define is everything. So from the cap all the way to the piles. If you need to change the pile configuration, you cannot use the OBM dialog boxes. You have to do it through the parametric cell or maybe create a new one, right? But at the end of the day, this element is just a standard microstation cell, and it happens to be that it's just parametrics, right? And select it and play with it as you would be with any standard element itself, right? And then it obeys the options like adjust to the deck, for example, right? Offset. So again, it's a fully reactive component on your of your pier. Now, what we are going to do as well for the release is that we're going to provide you with many cells, right? So you can get an idea on how these are developed and how you're going to place it. So the libraries are going to be included. It's going to be a tutorial as well. But then, as a heads up, I could say that if you research on our Learn server and you find the creation of parametric cells, so that's basically what we use, right? So you can just start researching on that as well as on the Learn conference of last year, 2018. It was a presentation and actually a hands-on workshop on parametric cells too. So you can just research on that and see how they behave, the constraints they can apply, and all of that. And you see the bearings, how the pier will just move down because you place bearings. So that's what make it functional. Because if you do it all by hand, well, you have to move the pier according to what elevation is being applied for the bearings, right? So, and with abutments too. So as I said before, we're focusing in this release on the uh, substructure part of it, right? And then this abutment, for example, has not as many variables as the other one, as the pier, but again, it's enough of the standard variables that my DOT does on the standard abutments too. So I'm fine on the maybe few parametrics that I created for this abutment because it just does it, right? So, and then again, I place bearings and it just changes it too. So, uh, we're very exciting on this development because, you know, the abutment part especially was something that a lot of our users requested. The ones that we do, most of them satisfy their needs, but there are some abutments that are special or they need a special configuration that we cannot provide through a dialog box. So the creation of these parametric cells, right, functional components, uh, basically will solve all these uh, custom piers or custom abutments that you may want to do. And then it's a solid element, so if you send it, in this case, this abutment, for example, lip bridge concrete or lip bridge steel don't handle that. So you have bridge then, as is going to come with OpenBridge Designer. So you can send this and bridge will be able to handle that configuration. You can do the calculations too. So at the end, you can compute it basically with any software that applies to the proper configuration that you have, either a simple bridge, complex bridge, steel bridge. Okay, so well, and that's all I have for today. We got 40 minutes on that. So this was the end of the presentation. So we're going to start with the question and answer session. I'm just going to pause the recording.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.